Periodic functions. A periodic function is a function that repeats its values in regular intervals, also known as periods. Due to this repetition, we can predict what will happen next based on what's happened prior. This is a very powerful type of function because when history repeats itself, it's good to help us figure out what might happen in the future. We'll look at several examples of periodic functions, and then we'll zone in on the ones that we plan to work on this semester. Let's look at some examples of periodic functions. So the first graph that you'll see here is a periodic function where one period is highlighted with the green. You can see that this graph is going to repeat itself as we move to the next stage. So it does the same thing over and over and over again, and we see it had done the same thing before. That's what makes it periodic. Let's look at a couple more pictures of some periodic functions. Here, we see some waves, and again, we start to see a pattern. You can see that there's a W shape here, and a W shape here, and when you look carefully, you see it's a repeated pattern. So therefore, that function is also periodic. Not all functions are easy to tell that they're periodic. Sometimes when you've graphed a lot of data, it's not always easy to see patterns. But if you look close enough, sometimes they begin to emerge. So here, if you look at this M shape, we can see that it happens again over here and over here. So from that, we can start to look at where the whole pattern repeats. And from there, we see a pattern that continues again and again. So that's another example of a periodic function. When studying periodic functions, there are two main things that we're really interested in that help tell us both about the function and about the predictability of what will happen later. The first thing that we're interested in is called the amplitude. The amplitude tells us how far the function goes from the center or midline of the function to the extremums, which is the maximum or minimum. Because the amplitude reports the distance we move above or below, it's directionless and therefore reported in absolute value. So the way we calculate the amplitude is to find the maximum y value of our function and the minimum y value of our function and find the difference between the two. We then take that number and divide it in half. You see the function formula written like this below, but we'll often write it as maximum minus minimum over 2, which means the same thing. So again, we're going to be looking for the maximum y value minus the minimum y value, and then we'll divide that in half. The other thing that we're really interested in is the period. So the period of a function is the amount of time or distance in terms of the independent variable that it takes to complete one cycle of the function. So we're going to be looking at the x values, and we're going to see how long it takes to start repeating our pattern. So let's go ahead and look at those periodic functions we were looking at before and see if we can find the amplitude and period for each of those. So our first example looked like this. To find the amplitude, we need to figure out the maximum value, the minimum value, and then we're going to take the difference and divide by half. So here, you can see that there's 1, 2, 3 hash marks. So the maximum value is 3, and down here, the minimum value is -1. So we're going to subtract those and then divide by 2. Be careful when you subtract a negative number. 3 minus -1 is going to give you 4. 4 divided by 2 is 2. So my amplitude here is 2, which means that if I were to draw a line directly through the middle of this function, which is not where the origin is, it's sort of here. I'll show you the middle of the function, that from that midline, my function varies by 2 units in both directions. My period is how long it takes for my function to repeat. So what I need to do is find a starting point for my function and then figure out where it starts to repeat. And I can do this at any point on my function. So here, if I start here at this first blue dotted line after the green, I can see how long it takes to get to the point where it starts to repeat. So I'm going to go 1, 2, 3, for 5 units. So it takes me 5 x units before I start to repeat, so my period is 5. Let's look at the next one. Again, we start by considering the amplitude. How high and how low does my function go? Now this one is not as nice because it doesn't have the hash marks and it doesn't look like I'm going to hit an integer. So here I'm going to have to do a little approximating. So I believe that 3 is roughly where I've put this line. Therefore, I'm going to say that my maximum is approximately 2.5. And again, I'm using the approximation symbols because I'm really not sure exactly where it is. From that, I'm going to subtract off the minimum. So again, my -1 is roughly here, and I would say that's about halfway between. So -0.5, and then I'm going to divide that all by 2. So 2.5 minus -0.5 is going to give me 3. 3 divided by 2 is 1.5. So my amplitude here is 1.5. My period is how long it takes for me to start repeating my pattern. So I'm going to start with this point right here, which happens at x equals 0. And then I'm going to see how long it takes till I get back to this peak. So you can see here that this peak happens again at roughly 6. So it takes me 6 units to start my pattern again. So my period is going to be 6. Let's look at the last one and see if we can find the same thing for this last periodic function. For this last periodic function, again, I'm going to have to do some estimating about how high and how low my function goes. So it looks like to me that the highest point is on the first part of the peak of the m, and I think that that's at approximately 4. And then my lowest point down here in the repeated pattern, I believe is going to be -4. So 4 minus -4, all divided by 2, is going to give me an amplitude of 4. Now, my period is how often I repeat. So what I can see here is that I've started at 10, and then I'm going until right about here. So I have to come up with a pretty good approximation of how far past 11 that is. I think it's a little more than halfway. I'm going to say that it goes out to about 11.6. But remember, I'm starting at 10. So from 10 to 11.6 means that I'm going to have a period of 1.6 units. So again, this is an approximation. You may have come up with 1.7, 1.65. That's all okay as long as you're in the ballpark of what I estimated as well. So let's go ahead and look at the functions that we're going to be studying for this semester. There's 2 functions that are periodic in nature that we're going to spend a lot of time talking about to model the things that we're interested in. And these functions are the sine and cosine functions.